So let's talk about limits and tangents. The main reason that we're looking into limits is to determine the slope of the tangent line to a curve. And as we move from a secant line to a tangent line, the change in x will approach 0. And what I mean by that is if we look at these 2 points on the curve, we know we could have this as a secant. But we actually want to get to the point where we can have it as a tangent. And in order to do that, we need to have this point of x get closer to this point of a. And then this change in x is going to get closer to this change when the function is at a. Okay, so as q moves towards p on this curve, then the line turns from a secant into a tangent. Okay, and by using the concept of a limit, we can determine the slope of that tangent at P, and that's at A and then f of A. So let's try an example. So we want to determine the slope in the equation of the tangent to the curve y equals negative 2x squared plus 5x plus 3. So the slope is the limit as x is approaching 2 of the function at x minus the function at 2. And this is all divided by the change in the x of in the change of x minus 2. So this limit as x approaches 2. So f of x is just this. So I'm going to put that in there. 2x squared plus 5x plus 3. And f at 2, I'm just going to quickly do that over here. F at 2. So I'm just doing this off to the side. So I have negative 4 4 times negative 2 plus 5 times 2 plus 3, which will give me 5. So then I'm just going to put in, I'll keep that in, as negative 5 all over x minus 2. Okay, I'm going to combine my like terms. And I'm actually going to get rid of this negative sign. This is just my personal preference. So 3 take away 5 is negative 2, but because I factored out that negative, I have a positive 2 in there. And now I should be able to factor this. Okay, so I'm going to have 2x on one side and x on the other side. And I just need to figure out where does the 2 go on which side. And I want the 2 to go over here so that I get negative 4 and negative 1. That's how I'm going to get negative 5. And this is all over x over 2. Now that I've done that, I can actually see that these two factors cancel, which is handy because I don't want to end up with 0 on the bottom, which is what I would have had before. After I do that, now I can just plug in the value of 2 as x approaches 2 into my equation. And that there's no denominator anymore. And so I'm going to get the slope of negative 3. After I've done that, I want to find the equation of that tangent. So I'm going to use the format y equals mx plus b. I'm using this as my point. 5, my slope is negative 3. I just figured that out. 2 is 2 is x, and b is my unknown. So b is 11. So then my final statement is negative 3x plus 11. And that's the equation of my tangent. Okay. So another way to look at this is to look at the slope of the secant or the tangent when we're looking at the difference quotient. So the difference quotient involves finding the slope using a value at h that is the horizontal distance between those 2 points on the slope. So this is really similar to what we were just doing now, except we're looking at the point f of a, and then some small distance away from a, which we're going to call h. And then the change in the rise of the function will be the change from f of a, f of a plus h, taking away f of a. Okay, so we're doing the same thing here. We're just kind of changing it up a little bit. Okay, this is going to be a little bit easier to use long term. All right, so let's do an example using this setup. Okay, so I want to find the slope of the tangent or, to the curve 2 over x plus 1 at the limit as x approaches -2. Okay, so I want to know as this change actually gets closer to 0, as h approaches 0, what is this slope here? Actually, I'm going to 0 here. Goodness. Sorry, I was using the last technique. All right. So this is going to be f at -2 plus a small horizontal distance over, take away f at -2, all over the change in the horizontal distance. Okay, so I'm going to plug in -2 plus h into the function as h approaches 0. So I'm plugging it into here. So I have 2 over -2 plus h in my x spot plus 1. Take away 2 over -2 plus 1 all over h. Now, I don't really like how that looks, so I'm actually going to say times 1 over h. That just avoids that double fraction look. Okay, so the limit as h approaches 0. So I'm going to clean up this part first. -2, so I have 2 over -2 plus 1 is h minus 1. And -2 plus 1 is -1. 2 divided by -1 is +2. And that's all being multiplied by 1 over h. And now I want to create a common denominator to get all of this over the same thing. So I need this to be over h minus 1. I'm going to multiply this by h minus 1. So I have 2 plus 2 times h minus 1 all over h and h minus 1. Okay, now I can use the distributive property to clean this up a little bit. I have 2 plus 2h minus 2 over h and h minus 1. I don't want to expand these brackets yet because I might be able to cancel something, and that's handier. Okay, 2 minus 2 is 0, so I have 2h over h and h minus 1. So this is going to cancel. So I'm just left with 2 over h minus 1. And now I can plug in my value of 0 here. So that's going to be 2 over 0 minus 1, which equals -2. I'm going to write my equation. Okay, I'm going to use my y value of -2, which I found here. My slope is -2 as well, and that happens at -2. So b is -6. -2x minus 6. Ooh. Okay. Okay, let's do one more. Before I start, I'm going to actually just to the side here, find f at 1. So I'm going to put 1 in for x. That gives me root of 4, which is 2. And f at 1 plus h. So that gives me 1 plus h plus 3. So that gives me root of 4 plus h. Okay, this just puts some of that work up the side, okay? All right, because I'm going to go the slope as the limit of h approaches 0 of f at 1 plus h, take away f at just 1 over h. And now that I've found those things, I'm just going to plug them right in. Okay, f of 1 plus h is root 4 plus h minus 2. So I'm just plugging these guys into this spot all over h. Okay, so I have a radical here that I'm going to rationalize, and I'm going to do that by multiplying by its reciprocal. Okay, so that's going to give me 4 plus h on the top minus 4 all over. I'm not actually going to multiply this in because I might be able to cancel something later. I don't know yet. Okay, now I'm going to, oh, these guys just cancel here. And this h can just cancel. So that simplifies pretty nicely. So on the top, I just have 1 and all over 4 plus h plus 2. And now that I can plug in 0 into this spot, I can actually solve it. 1 over 4 plus 0 plus 2 is 1 over 4. Now that I have done that, I can find the equation of my tangent. All right, I'm going to use the point here. So the y is 2, my slope is 1/4. My f or my 1 is my x value, and b is what I don't know. So b is 7/4. And so my final line is 1/4 x plus 7/4. Okay, there's a bit of homework, and that is all.